Okay, go ahead.
Yeah, okay, good morning everyone, and thank you very much for joining us this morning. Apologies to start with, we're having a slight technical issue getting our speaker on board there, just something going on in their own office setup. So I hear it's almost taken care of, so hopefully they'll be able to jump in pretty soon. So good morning everyone, and before we start, I'd like to do a little bit of association housekeeping, if that's okay. So a lot of people have said to me to tell that I should be maybe explain a little bit more about what the association does. And just a quick one on that. We have a lot of new members. We have a huge amount of people signed up today, so we have a lot of new people coming to us, obviously. So just to tell you a little bit about the association. So the BR Assessors Association is a volunteer-led organisation with only one paid member of staff, and that's Barbara, our indispensable administrator. All our committee members who steer the group are all volunteers. Our committee is proposed each spring at an AGM event, and the committee then nominates a chairperson, which is how I ended up here today. So we are open to new committee members throughout the year, though it doesn't have to be just at the AGM. And in fact, we have dropped off a few members of the committee, and that's normal. People come and go. But the committee structure at the moment is heading into its fourth year with me as chair, so it's high time for a bit of refreshment there. So as always, I'm urging people to get involved. A lot of members on here that are obviously members for quite a while. So if you've been sitting on the fence and having to think about it, please do get involved. Contact any of us, or if you think somebody needs a push, by all means propose them to me, and I'll call them directly, whatever needs to be done. About new membership, fresh involvement. Just on the membership itself, if you're not a member, of course, we'd urge you to join. The membership fee is pretty nominal, €120 per year. That's normally covered up to 3 members within a company, 1 to 2. We're in the process of putting a new scheme together to deal with the fact that, very positively, a lot of our members have become larger companies. So we need to reflect that in some way. So in the coming year, we will be dealing with that in 2026, putting out some fairer rates as far as that goes. What's the committee been up to since we last spoke to you, since our last CPT? Well, we have our ongoing engagement at SAI, providing feedback across multiple areas at the moment. So the association was asked to recommend a few members to go to test the new deep user interface, deep manual, basically. So there's a couple of strands of all related to the Energy Performance of Buildings Directive that's going on. So some people are looking at the deep manual, some are looking at the building passport and potential building passports. So we've been engaging with SAI and other stakeholders in that. We've been inputting to the traditional building scheme and the role of the new traditional building professional. So the engagement with the committee and the association is back and forward between SAI, Irish Green Building Council, the Department of Local Government, and all the stakeholders in that whole process. So, if you have an interest in all that, as I said, get involved with us, and we can have, love to get you as many people involved as possible. So I don't know, Barbara, have we managed to get our speakers in yet? I don't see anyone popping up just yet.
No, not yet.
Okay, maybe we will. Okay, that's a shame. Maybe we'll just. Sorry about this, everyone. Now, maybe we'll just mute off again just for 2 minutes to see if we can get them on board. They had said they were conference putting their hand up there. Is that them possibly?
Some people are saying that they have no sound as well, Stephen.
Right, you can hear me okay?
I can hear you perfectly, so it may be just their monitors.
It's generally your own setup, from my experience of watching many thousands of webinars. If somebody in Kildare can hear me in Cork, then it's probably your own setup, unless it's much more widespread. Okay, there's somebody on the phone there.
Okay.
Hello, Shane. Yeah, that's Cork Conference. Barbara, if you could let them in. Okay, Shane. Yeah. Yeah, we'll do that. Okay. So, yeah.
Okay, they should be in now. They just need to unmute themselves. There you go.
Good morning, gentlemen. Can you hear us okay?
Morning, lads.
Very good, great. That's great, guys. So I was just doing a bit of housekeeping there from the association, so you came in just the right time. If you want to maybe share your start screen there just to see if that's all working, and I will go ahead and do a little introduction for you. Eventually, I'm delighted to welcome this morning's speakers, Energywise Ireland, and I'm happy to welcome them. I've been hoping to get them involved in this for quite a while. So they're a Kerry/Cork-based company operating in Munster, who I've been working with for many years and always delivering great things and delivering great growth in all kinds of areas in the renewable sector. Energywise Ireland is one of Ireland's most trusted providers of renewable energy and home retrofit solutions, supporting residential, commercial and agricultural sectors with over 15 years experience in operation. The company has grown from local installers into a nationwide leader, recognised for exceptional workmanship, expert technical support and customer-focused approach. By working with the latest renewable technologies and global manufacturers, Energywise Ireland delivers high-performance systems designed to maximise efficiency, reduce energy costs and promote more sustainable future. From design to installation and aftercare, their team manages every step of the process with precision and professionalism, which I can definitely attest to. So I see there's 3 of you there this morning, but I have Eshaan Shevate on my list here as the lead solar PV designer, who I think will be leading this morning's presentation. Eshaan has been a key member of Energywise Ireland team for nearly 3 years, specialising in design and engineering of advanced solar PV systems with a strong background in mechanical engineering and a master's degree in renewable energy systems. He is passionate about delivering innovative, reliable and future-proof solutions and drive Ireland's clean energy transition. Shane is also there, who I know well, domestic sales manager in Energywise Ireland, who has been always a great help to myself throughout the years. I think you've one more there. You might have to introduce yourself. So I'll hand it over to you guys.
Yeah, thanks, Stephen. We've Trevor here as well, who will be kind of second in command to Eshaan on the design team. Thank you for the opportunity. It's great to have this opportunity to present this morning to you guys. Eshaan will be leading the presentation here. Maybe once we run through this, we can go through some questions at the end of the presentation.
Absolutely, thanks.
Everyone, my name is Eshaan. Stephen has already given a brief introduction about me. The CPD basically would be for about 30 minutes or so. Now I know you all would be familiar with solar PV as such, but just to make sure everyone is on the same page, we'll start from the basics and then gradually work our way towards the best practices or the best technology available in the market as of 25 or early 2026, and then any questions from then on, we can have a dedicated Q&A session after the presentation is over. And if you have any questions in the meanwhile, you could just probably pop them into the chat. And I hope that's okay, Stephen. We can just go through the questions towards the end then.
Yeah, that's perfect. Yeah, that's what we do.
Perfect. So I hope you guys can see the screen that I'm sharing. We can try from then on. All right, so we'll just start with the basics of solar PV, so solar photovoltaic, and what every building assessor would need to know when they're calling out for an inspection to determine what capacity the PV system or what impact the PV installation would have in terms of reducing the CO2 emissions or the dependency for that household on the grid. So basically, we have key components, which are your solar PV modules, which usually go on the roof, flush mount on the roof. A few cases, it could also be a ground mount system. Then you have DC cabling, which brings the DC power from the panels into your inverter. The inverter then converts that DC power into the usable AC, which is required to run your household loads. Then you have a metering and a protection component to it, which comprises of your isolators and DC shunts, a check meter to have a physical record of what has been generated from the PV in case there's any network issues with the inverter and the Wi-Fi. And then you have an optional battery storage, which again is a key component for storing excess PV for use later on in the day. We'll see how the battery can be implemented to maximize the use of PV or to maximize to reduce the dependency on the grid there. Then we'll talk a bit about the responsibilities of the key assessor. I know the deep methodology or the formula that's published by SEI, it takes into account just the annual yield without actually taking into account the efficiency of the panels, the type of solar PV modules that are being used, the height at which the installation is. So there's still a bit missing from the formula, I feel. But yeah, like to get the initial BER published, you need to know what size PV system has been installed and what impact that system would have for the household. Quick checks for that would be to have a PV nameplate module, which again is a requirement for your SEI grants as well. So that will tell you what the capacity on each individual panel would be. We need to make sure that they are properly certified, that the data that is on the documents is the data that you can see in the pictures as well. And then we need a safety or a handover file for each customer or consumer, which gives them access to all of the documentation, be it the ESP paperwork, be it the safety shutdown procedure, be it the warranty documents, or be it the data sheets for the inverters, batteries, and solar PV modules. So if you can just see the image to show in here, these are the PV modules which capture the diffused light as well as the direct sunlight from the sun. The photons in your PV panels, they convert electricity. They generate electricity and send it through the DC cables to your inverter. The inverter then converts that DC power into the usable AC power. That AC power is either consumed by the household, or if it's not required, it can send it on to your EV charger, or it can send it on to the hot water diverter. And if you don't have anything else, it can send it back onto the grid. The power on the grid, again, is AC. So that's why you do need an inverter to convert that DC power into usable AC. Right. So talking about the solar PV modules in the market at the moment, there's loads of companies offering monocrystalline panels and polycrystalline panels. The monocrystalline again give you a better efficiency, but there's a price you pay for that higher efficiency. And the difference between monocrystalline and polycrystalline basically is, in a monocrystalline panel, the silicon cells are of the same type, whereas for a polycrystalline panel, they can have more than 2 or 3 different types of silica cells in them. And that's the reason why the efficiency is a bit lower. The cost again is cheaper compared to a monocrystalline. And that's a bit outdated at the moment. I know this presentation says it's best for large installations, wherein if you have a ground mount system, a solar farm, for example, and you need a 650 watt panel or a 700 watt panel, the size of that panel is going to be extremely bigger than what you'd see on a regular domestic panel. That's the reason they still go with the polycrystalline, just to make it cost efficient for the installation. But yeah, and then there's a third type, which is the thin film. I think most of you all would have seen, be it on LinkedIn or TikTok, lads rolling out sheets that kind of resemble PV panels. Now these are extremely light in weight. Again, there's a drawback on these thin film panels. The efficiency is much lower. The end of life is unknown as of now. You won't be getting a 25-year warranty or a performance output from those kind of panels. And the cost, because it's a relatively, it's not too new, but it's still a relatively new and upcoming technology. That's the reason there's not many manufacturers out in the market who are producing these thin film solar cells or solar panels on a commercial scale. That is what makes it a bit uncertain to be used out in the market in full scale. So most of your domestic or your commercial installation that you'd come across would have panels that are monocrystalline. If someone wants a better output from the same area, the recommendation would be to go with a monocrystalline panel, purely because there's higher efficiency from those panels. There's a higher linear output that you can get throughout the life of the panel, which again is it could be 25 years or it could be 30 years. So the degradation in those cells is much lower than a polycrystalline panel. The next is the cell architecture. So I just have we just have to sample solar panels in here. Just to quickly explain what you mean by top con and what you mean by back con. This is a panel that's a top con panel, so you can see all these grid lines. I hope you can put just someone confirm if they can see the panels as well.
Yeah, we can see them. Kind of small though, I guess, because you're sharing your screen. So I'm just aware other people might be on a laptop. It might be very small, but generally we can see what's happening. Yeah.
I'm just going to stop sharing the screen there so that this can actually be right. So this is the first panel that I'd like to show you all. This, you can see the grid lines on the panel here. I'll try bringing it closer to the camera there. So you can see that the grid lines basically running all throughout the panel. Now this is a top contact panel. What it means is the black part is the silicon, and then the silver part is the contactor that will connect the two silicons, right? So this is the older or kind of the less efficient of the two types, basically. I'll tell you why it's less efficient as well. And then this is your back contact panel. You can see it's a very sleek looking. You can't really make the grid lines out of it. There are grid lines on this panel as well, a bit too difficult. And the reason for that is the cells are so compactly packed together in a back contact, that there's a solder, like consider a solder, but just on the back side of the cells, which means you can try and squeeze in multiple cells together. Squeezing multiple cells together means that this panel can actually absorb a lot of the irradiant sunlight and convert that into usable DC. So this will give you a higher efficiency. A back contact panel will give you higher efficiency than the top contact panel, just because there's a lot of coverage on this panel that can be used to absorb the irradiant sunlight compared to the other panel. It's just the basic difference that leads to the difference in the efficiency of those panels as well. Right. So that's basically the architecture for the PV modules, top contact or back contact. Now we'll just talk about this particular model that I showed you, the ultra black panel, and why the back contact is probably better in terms of producing more power. Let's say you have a 400 watt top contact panel. The efficiency from that panel could be 21%. But if you compare a 400 watt with a back contact, just because there's some extra solar cells built into the same panel, the efficiency from that module would be more than 23, 24. I think it's 24.3 or 24.5% efficiency on a few of those panels. They're much better looking up on the roof as well, with people now being very clear of how they want the PV system to look on the house. They don't want the PV system to draw unnecessary attention, but at the same time, they don't want that system to look or make their house look a bit weird. So they're worried about the aesthetics as well. So that's where the ultra black panel that doesn't really have easily visible grid lines be better than the old top contact panels. Again, these are black framed. You would have some panels which offer silver frames. It's up to an individual of what way they want the system to look up on the roof. But these kind of panels which are ultra black and have a back contact, they just are visibly more appealing. And they're just not visibly more appealing. They do perform better compared to the other panels as well. So that's the reason why it would be recommended, or it should be a recommendation, to go for a panel which is back contact, just so that you can get more juice out of those panels from the same roof space available compared to the other kind of panels out there. Right. One more thing quickly that I'd like to mention on the back contact technology as well. We'll get to this part eventually further down in the presentation as well. Contact, there's kind of bypass diodes as well built into the panels. And what this means basically is, previously, if one panel, or if there was partial soiling on a panel, be it bird droppings or be it dry leaves or be it any sort of debris accumulated on a panel, the performance from that entire panel or that entire section of the panel would be affected, and ultimately the string performance or the performance from the inverter would be affected. With the back contact and the bypass diodes in this, what happens is, if there's soiling on a particular section of the panel, that part of the panel is bypassed, and it moves on to the next set of cells in here. So it doesn't affect the performance of the string by an awful lot. So on a regular panel, let's say, it could be affecting the performance of a string by 10 or 15%. or maybe even up to 50%. But with this kind of technology, you're kind of bringing the performance loss as close to negligible as possible. They, of course, will be some performance loss, but it will be negligible. It won't affect that entire section. It will just affect that one cell on the panel, and then it will move on to the next cell. Once the debris is clear, or the hotspot or the soiling is cleared, that cell comes back into action and starts producing at full capacity. But even with the partial soiling, it won't impact the performance by a huge margin. The effects of shading on PV systems. This is one key requirement that you'd have to get on the deep software as well. What sort of shading would a household be prone to? It could be from chimneys, it could be from overhead cables, it could be from the neighbor's roof. And again, it is a bit difficult to determine that if you're visiting a house early in the morning, you'll probably only be able to figure out the actual extent of shading at that time of the day. The scenario would be different if you go call out again for an inspection later in the day. But that's just some key assumptions you have to make when you're putting in your calculations on the deep software. Why shading is disproportionately harmful on the strings. So let's say there was soiling on a panel here and it wasn't noticed, let's say, for a good few months. So while the other cells are performing at peak capacity and this particular cell in the corner is being bypassed, the other cells have a different life cycle compared to the cells in this. But the crystals in the other cells are going to be different compared to this area. What that means is if you have a thermal drone and if you fly that drone over a particular panel to see, you could come across hotspot formations. And what hotspot means is that the panel starts heating because it's trying to bypass that particular area, which can ultimately lead to the panel, losing out on its efficiency completely. So it's having bypass diodes is crucial rather than just having one or two bypass diodes in a panel. But you also need to make sure that the shading is not permanent on the panels. Otherwise, the panel is going to develop hotspots somewhere in the future. If there's minor shading, let's say if there's an overhead cable that causes shading onto the panels at a particular time of the day, we can't really be doing anything about it. But these panels, they're kind of built to withstand that, as in the shading from an overhead cable will change throughout the day. So it won't just be impacting one particular section of the panel. It will keep on changing as the day goes on. So that won't lead to having any hotspot formations onto the panel. The next one then is there's almost all of the panel manufacturers out there, they're offering the half cut cells. And what a half cut cells means is
You seem to have frozen there. frozen there, Stephen.
Yeah, I think so. They look like they've lost their connection there. Yeah, we'll get them back on board there. Just to say, I was just putting in the group there, of course, put in any questions as they come up in the QA, and for CPD points. They'll be sent out automatically at the end of the presentation, hoping we get to the end of it. And if you don't receive them for any reason, contact Barbara there at administrator at BR Assessors Association, and we'll get you sorted. So they've seemed to have dropped out completely there. Joys of live television, folks. Yeah, the gremlins seem to be very much taking hold in the north side of Cork City this morning. Yeah, a good few people saying about the sound this morning. I don't know, is the sound system here where I am seems to be pretty good, but I'll maybe say to them if we get them back on to move a little bit closer to their microphone. I guess if it's on a laptop or something, it might be harder to hear. I see a question in there from Kevin McCourt. Probably not so much for the guys anyway, so I think it might be a comment that's worth making, I suppose. And given that a BR certificate is calculated and published on the basis of the energy consumption of the dwelling for space, heating, hot water, ventilation, and lighting, why then is the total produced for a solar PV panels included or offset in the energy consumption of a dwelling, when the electrical energy consumption of a dwelling with a gas or oil-fired central heating system is in the context of the BR is only used for lighting, central heating pumps and fans? Yeah. Don't know, Kevin. I suppose it's probably a question maybe for SAI directly or whoever's putting DEEP together. It certainly gives a lot of credit to PV, and seem to be a lot of things in DEEP seem to be pushing or giving great rewards to PV. So maybe they want to drive that. But yeah, I'm not sure anyone here can really answer that. So Barbara, it's gone over to Shane Murphy there. You can see him putting up his hand. Can you give him access to the screen? They're just going to switch over the laptop.
Sure,
Okay,
just one
Shane.
second.
Apologies about this, folks. We often wondered, we thought we were getting away lightly over the last 10 or 12 presentations. They all had gone very smoothly. So I guess our time has come. So Shane is going to jump in there just on the laptop now only.
He's there. He just needs to unmute himself.
Yeah, unmute and open your camera, Shane.
We'll continue on this screen there, but we have Shane logged on in the background just in case there's any.
Okay. Well, we can see
Switch that we have to make.
So yeah.
Unfortunately, it doesn't seem. Yeah. I'll just quickly start that entire slide again because I'm not sure where exactly we froze. Yeah, and rather than switching between slides and camera, I'll just stick to the presentation. And then during the Q&A, we can.
That's fine, yeah.
Perfect. I hope we're back.
Yeah, we can see your presentation, yeah, and hear you very well. Go ahead.
Perfect. I'll just go back and quickly explain the half-cut cells again. It basically means that the upper half of the panel and the lower half of the panel, they kind of work independently. So if the lower half is impacted by any sort of shading, the upper half could still perform at peak capacity and vice versa. So that kind of gives the panel a bit more freedom in what it can do to give you a better output from the entire string rather than completely affecting the string performance. There's ways that you can avoid complete shading and the impact it'll have on the performance of the string. The two ways to avoid shading, the first one would be to put in an optimizer. The optimizer again is a bypass diode. So if you have 10 panels connected on one string and you know for sure that 2 of them are going to be impacted by a chimney right next to it. But this would only be from, let's say, early morning up to midday. You'd optimize those 2 panels. What that'll do is in the morning when the chimney is casting a shadow on the 2 panels, the optimizer will kick in. It'll stop any production being impacted by the shaded panels, while the other 8 panels can keep on performing at their own capacity. So instead of the 10 panels being affected, it's only going to be 2, but still the 8 panels on that string can drive on and keep on producing until the 2 panels kind of match the same level or the same output around midday. And then on, the optimizer falls back and it lets the PV panel do its job on its own. There's, however, a drawback of using optimizers. I know there are certain inverters out in the market that do require you to have an optimizer, but there's certain drawbacks as well for an optimizer. The optimizer will kind of modulate the PV panel throughout the day instantaneously. So if there's any shadow on the panel, the optimizer kicks in, and that will ultimately impact on the life of the PV panel because there's a lot of external modulation going on, and it kind of restricts the output from that individual panel. So wherever possible, try to not use an optimizer. Go for the other method instead, and the other method is the use of microinverters. Microinverters, as the name suggests, it's the smaller version of a DC AC inverter. But instead of 10 panels being connected to one PV inverter, a microinverter can be added individually to a single panel. Let's say you have a terraced house and you don't have enough roof space to get a decent size system, but still having, let's say, 3 or 4 panels is going to be making an impact on the total BR rating for the house. In that case, the micro inverter comes handy. You can have 3 panels facing one direction, 1 panel facing a completely different direction, and let's say other 2 panels facing the third direction. The reason why a micro inverter would be handy here is you can the output from that 1 panel facing, let's say, a south orientation, the microinverter will be able to capture that as well from the panel without having to meet a specific voltage limit, or without being connected to the other panels on which would be facing different orientation. So it might be a case that you don't have roof space enough to get a decent size system or even smallest possible size system. The microinverter can be used there. That will allow you to install even a single panel if that is going to make an impact on the BER rating. This really comes handy where you have a house that is trying to qualify for the BEC or the one-stop shop scheme. So the other upgrades can get the house to a specific rating, but there's that one particular bit missing, and that's where the PV can be implemented. Even if the homeowner doesn't have suitable roof space to go for a bigger system, a small PV system in that case could make a big impact to help them achieve that particular BER rating. The microinverter, again, it unlike the optimizer, it doesn't give any feedback to the panels. So it is not impacting the operations of the panel itself. It's only taking power from the panels. So it doesn't affect the life of the PV module. So it's a better alternative compared to an optimizer. But the optimizer, again, it's not all drawbacks of using an optimizer. The optimizer does give you a better monitoring over your system as well. As in, if you have 10 panels and all 10 of the panels are optimized, you can go and have monitoring at a module level. So you know exactly which panel is performing better compared to the other panels. So in case there's a call out required or there's a assessment that you need to carry out on the roof, if your system is not performing as it should be, you just by looking at the monitoring app, you can exactly tell which panel is impacted, and that kind of saves time, saves effort as well. It helps you identify what the exact problem is, and then you can get working and either change that module, or change the optimizer, or it could be something what to do with the DC cables. So the optimizer does give you a better control over the system, but then the drawback is that it kind of impacts the life of that panel. So again, depending on what the situation is, you could either go for a microinverter or you could go for an optimizer. The microinverter probably would be an expensive option here, because you need one microinverter per panel or one microinverter per 2 or 4 panels. And that means each microinverter will have its own set of isolators and all the protection equipment. So that might be a dearer option. But if it gets you that particular BER rating, it's worth going with a microinverter. Again, with the microinverter, because there's one microinverter per 2 or per panel or per 2 or 3 panels, that also gives you that module level control over your panels just to figure out how each panel is performing, and if there's any changes that you need to do on the system, or if there's any cleaning that's required, or if there's any impact from a hotspot on the panel, that can be identified from the microinverter as well. Coming back to the site survey checklist. This is more when you are recommending a PV system to a consumer. The first thing is to identify where the PV system could be going. The second system, the second part would then be to make sure that that roof space or that area is shade free as much as possible. With the latest technology in panels, if there's partial shading or there's shading only at specific time of the day, that roof space is still viable. You can still have a decent size PV system put up there. But the first priority should be given to roof space that are unobstructed and have a shade-free area that the panels can go on. The second one would then be to see what size of PV system would the household require based on what their annual consumption has been. People do want to future-proof their PV installations, especially since the last 2 years, because it's been VAT exempt and there's SEI grants. Everyone seems to be wanting to get more and more systems installed. But we need to know exactly what the consumption is so that we can recommend what the PV system should be or what size of PV system would be required to meet that requirement, and then have certain surplus that they could either save in the batteries or they could sell that excess off onto the grid. Right, so moving on from the panels on to the inverters. There are two types of inverters. The first one would be your string inverters. The string inverters are the very simple devices which take input from the PV panels, which is DC, and they convert that into usable AC. And that AC is then fed to your meter in the house to look after your loads. And if there is no power being consumed in the house, it can be sent on to the grid, and you can get some credits out of that exported electricity. There's a term called MPPT, which is the maximum power point tracker. Most of the domestic inverters that you'd come across would at least have 2 MPPTs. What MPPT means is so let's say there are 2 MPPTs on a string inverter. The first MPPT would be independent from the second MPPT, which means if you have an east and west PV system, the panels on the east would be performing on their own without affecting the panels or the performance from the panels on the other side of the roof. That gets you a more constant output through the inverter. The more number of MPPTs, the better the inverter and the installation would be. In terms of if you have a standalone bungalow with a good south-facing roof, but that cannot probably take too many panels. In that case, you'd have to use the east and west roof as well. But because the string inverter in this case is only with 2 MPPTs, you have to let go of the south-facing roof and only go with the east and west-facing orientation, which kind of affects the performance of the overall system. Had there been an inverter with 3 MPPTs, this would have been more handy in this installation, as in you could have 5 panels facing south, 4 panels facing east, and 4 panels facing west to make the most out of the inverter as well as the available roof space. So the more number of MPPTs you have, the better it is to design the system and to get more from that installed system. Again, the reason why a string inverter would make more sense is because it's cost effective. It's much cheaper compared to a hybrid or a battery ready inverter. There's no provision on a string inverter to add a battery at a later stage. So if you're recommending a customer to go for a string inverter, they cannot add a DC coupled battery to the same inverter at any stage in the future. So that's a drawback, and that kind of makes it more cost effective as well. Is limited on the total expenditure. A string inverter does come handy in this case. Again, if there's a complex roof, like I mentioned previously, where you can't get a suitable size system on a roof, microinverters would be handy. Again, microinverters are string inverters. You cannot have a DC coupled battery connected to a microinverter. And then the next one would be a hybrid inverter. And what a hybrid inverter has in excess compared to a string inverter is that it can be connected to a battery, a DC coupled battery. So if you're not consuming the PV, the production from the PV, and you don't want to sell that onto the grid either, you want to save or you want to store that energy for use later in the day, that's where the DC coupled batteries come into picture. So you can save that electricity into your batteries and then discharge them later in the day. Again, PV is seasonal, so the performance from your PV system kind of changes as the season, as the weather changes. So during winter, you can set the batteries to charge on a cheaper night rate and then discharge whenever you want during the day. And the same batteries can then be set to charge purely from excess PV during summer months. So there's a bit of flexibility that you get with a hybrid inverter. And
picture was gone. It's nice little strings.
yeah, that's right.
Okay,
So
we can still hear you good, but your picture froze and the slide has moved on now. So, but we can hear you. So carry on.
Oh, perfect. Yeah, I am still on the hybrid inverter part here. I'm going back to the capability, the capacities and the capabilities of your hybrid inverter. So like I mentioned, you can set a time of charge on the batteries during winter months. Let's say someone has a cheap EV rate from 2 at night to 4 in the morning. They can set the batteries to charge on that very cheap EV charging rate and then discharge that power during the day, especially during winter months. But then come summer, when there's definitely going to be excess PV, you can have the batteries set to charge purely from the excess PV rather than selling that back to the grid. So it does give you a bit of flexibility. There's usually a backup socket with the hybrid inverter in case of a power outage. The energy stored in the battery can be accessed through the backup socket. Again, these are DC coupled batteries, which means if you have a 7.5 kilowatt DC system installed with a 6 kilowatt inverter, and the inverter is only going to give you 6 kilowatt AC output. But there's going during a peak, let's say a day in June, 21st of June, when the PV production is supposed to be at peak, the 7.5 kilowatt of DC is going to generate 7.5 kilowatt. So in that case, what happens is the additional 1.5 kilowatt DC goes straight to your batteries. And then the inverter is still giving you the 6 kilowatt AC output. So this is where your DC coupling comes into handy. You can oversize the inverter, as in you can go with a higher capacity DC system, but still have a 6 kilowatt inverter onto it. Most of the hybrid inverters out in the market at the moment, they allow for 150% to 200% oversizing. It's not recommended to oversize them 200%, but if required, you can have them oversized up to 200%, and it'll still perform without affecting the health of the batteries or the health of the hybrid inverter. And I'll come to that section shortly, as in why oversizing is recommended, but just giving you an example of what DC coupling needs. Now, just the pros and the cons of going with a hybrid inverter compared to a string inverter is it's a bit more expensive, dearer to go with a hybrid inverter again because there's battery involved. So that does make it a dearer option. But it's future proofing your system. You can add batteries later on within a certain period, of course. But you can add on the battery storage. At the moment, if there's any excess PV that's exported back onto the grid, you do get paid. But eventually, few years down the line, the tariff is going to go on decreasing. So people would want to make sure that they are saving all of that excess electricity rather than sending it back onto the grid. So that's where a hybrid inverter would be useful. They won't have to change the entire setup. A battery ready or a hybrid inverter can future proof that system. It's slightly lower in the peak efficiency, and the reason for that is the hybrid inverter is converting DC into DC for batteries, and at the same time it is converting DC into AC for your household loads. So it's doing twice the effort compared to a string inverter. That's the reason why there's a lower efficiency, but again, it's negligible. The efficiency drop on a hybrid is negligible compared to a string inverter. And the installation part is a bit more complex just because there's batteries involved, and it's not just a plug and play compared to a string inverter. The newer hybrid inverters in the market that probably would be launched in January 2026 or sometime in the first or second quarter next year. They are moving on to a plug and play setup. The architecture would be much more simpler compared to the existing hybrid inverters. So yeah, that technology is evolving as well. So it would be a much easier installation going forward once we have these systems out in the market. Yeah. Again, there's DC coupled and AC coupled battery systems. The DC coupled would make more sense. The AC coupled, if someone has existing PV and they want to add batteries 3-4 years later on, or they want to make use of the old batteries that they have, they would need a AC coupled inverter. Not recommended by us because you'd need to inform the ESP and seek approval twice. One would be for the DC coupled solar PV inverter, and then the other would be for your AC coupled battery inverter. And there's a high chance that the ESP might come back saying you can only have one inverter installed, just to make sure that the grid is stable and everything. So it's really important that we push for more DC coupled batteries that can go with excess PV compared to AC coupled. But again, AC coupled is an option where there's no PV possibility. Right. Moving on to the solar panel orientation for Ireland. Again, because Ireland is in the northern hemisphere, the sun is to the south for most part of the year. That's the reason why south facing is the optimum orientation for any solar panel installation. If there's a east-west facing roof, again, that would be your second option. The south is again the best one, but just because someone has east and west orientation does not make that system any less efficient. In a domestic installation, your consumption is high early in the morning when people are either getting ready for offices or they're getting ready for schools and colleges, and then later on in the day. So the east-west does make it more convenient in that case, as in the PV on the east-facing roof would be peaking early in the morning when you have a high consumption, and then the PV on the west would be peaking later on in the day when everyone is back in the house and you have the electric stove on, or there's hot water required at that stage. So both systems have their own benefits. ideally a south facing would be the most the better out of all the orientations, particularly for any installation in Ireland. The annual yield, again, I'm not sure if the screen is back on. Yeah, but this value here, I'm trying to highlight it, 850 to 1000 kilowatt hours per kilowatt peak. That basically is the specific yield from a system. If you don't want to get the deep calculation done, or you don't want to be using any softwares, just purely by looking at the system size that's installed, you can multiply that system size by 850 or 900 or 1000 to get what the predicted annual yield from that system could be. So to give you an example, a 6.5 kilowatt system, I'm assuming that the specific yield is 1000. That system would generate 6,500 kilowatt hours annually. Now, this is just a predicted yield for quick calculations. The deep methodology will give you a better value. But just in case someone wants to recommend a system purely based on, just to figure out what system size would be suitable based on the consumption, you could just use this thumb of rule and multiply the system size by 1000 or 900, and that will give you a somewhat closer system size. Right, moving on to the next one. Moving on to the mounting of the system, like I mentioned, almost 95% of the installations in Ireland are roof mounted. But you do have other options as well. The first one would be the pitch roof. Again, the ideal pitch on the roof in Ireland is somewhere between 28 degrees to 30 degrees, making it very ideal for installing panels flush mount. The panels would be on the same pitch as the roof, making it look a part of the roof itself. Or you also have mounting frames that can be used on a flat roof mounting. The pitch on those isn't too high because you have snow loads and wind loads and everything acting on the panels, so you can't be having a 30-degree pitch on those flat roof mounting when you're just using a ballasted system. But yeah, you can have a 10-degree or a 15-degree pitch onto those mounting systems as well to get you an output from a flat roof system. Then you have the in-roof or the building integrated PV system. These are frames that make up for building materials. So it could go onto your roof, and you could replace your tiles and just have a frame on the roof itself that sits onto your battens, and then you can mount PV panels onto it. Now there's a bit of a debate, or it's unclear to some if a building integrated PV or an in-roof PV system would qualify for the SEI grant. If it's an in-roof system, it does qualify for the SEI grant. It's just the solar tiles that don't qualify for the SEI grant. So they cannot, if you have PV panels, if you have PV modules, it does qualify for the SEI grants. But if it's solar films that go onto your glazing, or solar roof tiles, which are standard, which are kind of a replica of your building materials, in that case, that does not qualify for the SEI domestic grant. So just a bit careful on that wording there. And then, of course, you have a ground mount system. A ground mount system would be in an area where you have a shade-free a shade-free ground access that is suitable to have a pile-driven or a ballasted system. Now, this system, you can have a 30-degree pitch as well. And the reason for that is that the piles go about 1.5 meters deep into the ground. So it holds the system securely in place to withstand any wind and snow loads acting, any uplift acting on the mounting frame. Again, it's recommended to have these kind of systems in the backyard rather than having them to the front. From a safety point of view as well, we don't want any glazing from the panels to affect the oncoming traffic on the road to the front of the house. So there are certain requirements and code of practices published by the ACI, but down mount is an option if you don't want the panels up on the roof anyway. I mentioned wind and snow loading acting on the panels that kind of determine if a roof can take a PV system or what the loads would be. So there's plenty of softwares available online that can give you or that can generate a specific wind and snow load. It's important if you're not certain if a roof can take that system. It's important that we take a structural sign off as well, and the PV system is installed as per the manufacturer's guidelines. So again, K2 base is one of such softwares that gets you the actual load that would be acting up on a roof. And the key inputs on that is the area where you're installing the system, the height at which you're installing the system. If there's any obstructions nearby that will kind of block the impact of wind acting on that roof, and also the weight of individual components that make up for the entire PV kit going up on the roof.
Just go into the deep calculations, renovating. Yeah. Show kind of the difference between what is and what should be.
So just getting on to the deep, this is what most of you would be using to calculate what a PV system would be impacting or what a PV system would do to benefit a consumer's energy dependency. It takes into account the total peak power that's installed. It takes into account the overshading factor. Again, these values are mentioned on in the H2 table. I think even the latest release, these values would be mentioned. And then the system loss factor is what you take into account. But these figures, again, the formula that the calculation uses, it does not take into account the efficiency of the modules or a combination of the modules and the inverter. If, for example, if I were to use the deep method to calculate a 6.5 kilowatt system installed in Cork, it'll give me the same result for a system installed, a 6.5 kilowatt system installed in Donegal. So we know for sure that the two systems are not going to be performing at same capacities, or they're not going to output the same capacities. But if you use the deep calculation, it will give you the same kind of output. So again, the deep calculation is not robust. It does not take into account everything. That's probably what needs to be introduced in the next versions of the software, taking into account what kind of modules you've been using. There's plenty of other softwares and simulation methods that can be used to determine what a particular install can give you, depending on where exactly it's installed, what the height is, what materials have been used, and what combination of PV modules and inverter have been used. I am going to quickly run through this again. ESP documentation is something required. Every PV system needs to be informed to the ESP. The inverters that we need, or the inverters that are recommended to be used, need to have certain settings and specifications that AirGrid and ESP have laid out. all the manufacturers do comply with these regulations, but you need to have a specific Irish grid code on the inverters. That's something that even the VRSSs could manually check, because that's something that the SEI inspectors look for when they go in and witness or inspect any PV installation. So it's the Irish grid regulations that should come up on the inverter settings. Maintenance and performance monitoring. All the inverters do come with their own monitoring apps. A customer should have access to these. Most of them are well equipped with identifying if there's any issues, alerts, warnings. It does notify them, the consumer, and you can act upon them as quickly as you can. Maintenance, a PV system does not require high maintenance, but just a visual check every 6 or 7 months should be enough to make sure that there's no visible debris accumulated on a panel, so that the panel can be performing without any hotspot formation onto them. Economics and future considerations. There's of course grants offered by the ACI. There's export payments announced by the CRU, which means if you export anything back onto the grid, you do get paid. The rate at which you get paid depends from supplier to supplier, and these tariffs could change year on. So there's no guarantee that if someone gets 18 cents for exported electricity this year, 3 years down the line, they might not get the same value. It could go up or it could go down. That's where your battery storage again comes into picture. You can add batteries later on to maximize self-use, and that's what the ideal recommendation should be. Because with batteries, there's a bit of flexibility that a consumer gets in terms of meeting their own demands and also offsetting the day usage with a cheaper night rate. So that has economical impact as well. It's the same thing, just with further examples for roof orientation and location selection. Right, we went through this initially in the system sizing methodology of what the best system size should be, what the recommendation should be. It all depends on what the consumer is consuming in an annual year, and then future-proofing that system to take on a bit more in the upcoming years. So 12 months of bills is something that we usually require, or we usually ask for, to determine what the annual usage is and then recommend a suitably sized system. But on the domestic side, people do want to future-proof it. So even if the consumption at the moment is 5,000 kilowatt hours annually, they would want a system that will give them 6,500 kilowatt hours annually, just to make sure that any demand in the next immediate future can be met by the PV system. Peak shifting and management with battery storage. Like I mentioned, your batteries can be used to offset a specific, you can use the batteries to charge on a cheaper night rate and then discharge them during a specific time that will offset your peak during the day, or you can charge them purely from the excess PV and then discharge as and when required later on in the day. So it gives you that flexibility, and it's highly recommended to go with a battery ready, either a battery ready inverter or a hybrid inverter with a couple of batteries. These are the documentation basically that every company should be giving out to the consumers, and it's the responsibility of the consumer as well to make sure that they have this documentation with them. Part of which again is required by BR assessors as well, which would be your BR confirmation certs or an estimated yield report that tells you what kind of generation that PV system at that particular location would have. You need to know what PV modules have been used, what the efficiency on those panels is, what the inverter could do, if there's battery storage built into the system, if there's proper documentation done, as in if the ESV have been properly notified about it, if there's a safety or a shutdown procedure printed and posted right next to the inverter and the battery location. So this is something that every company or every installer needs to give as part of a handover package to the consumer, and it's the responsibility of every consumer to make sure that they have this package after the PV installation is done. These are just practical examples of what the deep calculations would be, assuming that the base yield, we like to call it the specific yield, is 9,000 kilowatt hours. There's a table in the deep manual that gives you these figures depending on what the orientation and what the tilt on the roof is. So for a south facing roof with a 15-degree pitch, it'll have a specific value. For a south facing orientation with a 35-degree pitch, it'll have a different value. So taking all of these figures into account and using this formula, you can calculate, or this is basically the formula that the deep methodology uses. Like I mentioned previously, it does not take into account the efficiency of the modules or the efficiency of the inverters or a combination of what inverter and what PV module is used. So I think that's something that should be introduced as soon as possible. That will give you a better idea of what the system could actually generate. One quick observation as well, the irradiance values mentioned in the deep table, they're actually for solar thermal and not for solar PV, which means is if you have a PV installation on a bungalow, it's saying you'd get the same irradiance compared to a 3-story tall house, which again is not the case. Your irradiation values would change depending on how high you are off the ground. So that's something that simulation softwares take into consideration, but the deep calculation does not. So the deep calculation is a bit more conservative compared to what the simulation softwares can give you. So for example, if a deep software is giving you, let's say 5,500 kilowatt hours annual generation, we've seen this on so many previous installations that the actual recorded generation from that PV system is much more than what the deep calculation would have predicted. So that additional 300 or 400 kilowatt hours that's actually generated could impact and get the consumer a better BR rating. That is something that needs to be accounted for probably in the next versions of the deep formula or the software. This again is an example or the graph showing the east and west facing installation compared to a south facing installation. Each system has its own benefits, but ideally a 30-degree pitch facing true south would be the most efficient or the most ideal roof to have PV panels installed in. Again, if there's a mixed roof scenario, this is probably something you guys would be coming across as well. If there's panels on 3 different orientations, the deep software requires you to calculate each roof individually and then club them on. That might not necessarily be the case if it's not a micro inverter and your inverter only has 2 MPPTs. That means you have panels on 2 different orientations connected together. So the impact is going to be affected. So the deep calculation in this case probably would be a bit over ambitious compared to what the actual yield from that system could be. But But again, this is it at the moment it cannot be implemented into the deep software. Yeah, so that's basically the end of the presentation.
Okay, thank you very much, Eshaan. That was fantastic. I think what we we learned from that really is that what from a lot of BR assessors look at as kind of a simple process of calculating yields and panels is that behind it there's a lot of technology and a lot of advanced learning. And I think you've given us, you know, a good oversight of some of that kind of language and just some basic knowledge of what a lot of these technologies are and what's coming in the future, and certainly take into account, you know, that obviously you as an industry and maybe us as an industry does need to be pointing that out to SAI that this 0.8 factor that we've been using is a little bit out of date and certainly needs to move on with the times. So yeah, so some people were asking about slides and videos and everything. Obviously, we've gone a good bit over between technical difficulties and the amount of technical data there. So this, all our webinars are available online for members, so in the resources center, so you can watch it back. So obviously, if you have to head off now or whatever, you'll be able to watch that back. You'll still get your CPD. Hopefully, I can ask the guys to share the slides because there was a lot of data in there that we can maybe include that as well. So we will take a few questions, and obviously if people have to head away, they have to head away. There's not too many in here, and a good few of them, I think you might have sort of covered them. But obviously, the fact that the slides and presentations are there was one for sure. So I'll just have a quick look at a few on the Q&A, and then John might just jump in with some on the chat. So we addressed Kevin's one, I think. What's your opinion on bifacial solar panels with cells active on both sides of the same panel? Oh yeah, so there's yield from the back of the panel. I think that's what that means, isn't it?
So bifacial panels, it's important to realize that the bifaciality only comes into picture if it's a ground mount installation. A bifacial panel is redundant if it's used up on a roof. It does provide better protection, but the bifaciality does not come into picture. There's not enough distance between the backside of the panel and the roof for the rays to hit and then reflect back. So it's a lost cause on the roof itself. It does provide better protection. So yeah, it can be used up on the roof from a protection point of view, but if it's a ground mount installation, the bifaciality definitely does make a good bit of sense. There's about 15 or 20% of jump in the output from individual panels.
Yeah, that's obviously 15-20%, but yeah, ground mounted only. Great. From which string size is a hybrid inverter worth to invest in?
Most of the hybrid inverters out right now are 5 kilowatt, 5 kVA and 6 kVA as per the NC6 requirements from the ESP. So if someone wants to future-proof their system, we'd recommend going with a 6 kVA hybrid inverter. And a positive side of going with a 6 kVA inverter at the moment is even if you have 8 panels installed at the moment, but you want to add in the future, the inverter would still be useful with the 8 panel current installation and then take on more panels in the future. So try to get the 6 kVA hybrid inverter irrespective of the string size that you have. Again, if the house is very small and it can only ever take 7 or 8 panels, you can go with a smaller hybrid, which is again, I think a 3 kilowatt or 3.6 kilowatt. So yeah, I think that should yeah.
Is before I jump over to John there from the other list, is the under voltage lock protection for the batteries in the inverters? Is the under voltage lock protection? Yeah.
There is most of the hybrid inverters are pretty smart. There's a BMS built into them that look after the voltage on the batteries as well. So the moment the voltage on the batteries starts dropping, it brings up a warning or it brings up an alert, and it stops discharging the batteries itself. So I think that answers the question. It is a possibility with the hybrid or the battery ready inverters that do have a battery management system or a BMS with it.
All right, thank you. John, you have some from the chat?
Yes, first one there from Michael Hanratty is what is a typical payback for a battery system?
Typical payback for a household with a battery storage system would be somewhere between 6 years. And I'll tell you the reason why it's 6 years is because a battery can come into play in different ways. The same consumer could have the battery set to charge from the grid during winters and then from excess PV during the summer months. So it's really difficult to put that into a simulation when you don't exactly know what the consumer is going to be making out of the batteries. But purely leaving it as purely considering the fact that they want to leave it to charge from excess PV, the payback would be somewhere between 6 years to 7 years.
Okay, thank you. Just from John there, we have, can you please confirm if you can connect a second battery at a later stage without having to change the inverter?
It all depends on what generation cells you have on the first battery. We usually recommend adding the second battery within the first year. You don't really need to change the inverter at all, unless the old software or the old firmware on the inverter makes it difficult to add more batteries in the future. But the newer generation cells in the batteries itself, they can take more and more batteries even a couple more years down the line as well. So there's no mismatch in the cells that are used, but that's only the very latest generation of cells. We probably don't have them available in Europe as of now, but that is something that they showcased in all of the solar expos as well. So that is something coming on. When you can add a battery 3 or 4 years down the line and it should work with your existing setup without having to change anything.
Okay, thanks. So then Niall Farrell there is, have you ever installed a system with oversized batteries that in wintertime are fed with nitrate electricity from the grid and then used in the house during the day? Would there be certain size of system for this setup to be a cost-effective option?
It again depends on what your consumption is. We have oversized the battery storage on particularly on farms, wherein the PV peaks during the middle of the day, but the consumption is either early in the morning or late in the evening. So that's when the batteries can be used to discharge a huge dump pretty early in the morning. It depends on what the consumption is and what your day usage and night usage is.
Perfect. Okay. So one other one is let's see, why aren't there triangle-shaped PV panels used in Ireland? So many semi-roof types lose so much space when the panels are large rectangle. So that's.
I think a triangular shape of PV panels makes it difficult to mount the panel onto the roof. It might come handy to use all bits and pieces of the roof, but again, the system is basically designed to be up on the roof for 25 years. So if the clamping and the mounting is not proper, that could have a negative effect on the entire structure itself. So purely from a wind loading and a structural point of view, a rectangular or a square shape on the panel is something that's sturdy enough compared to any other shapes.
Okay, and we'll just take one last one.
Just to follow up on that, we can mount the panels landscape and portrait as well, and a combination of both. So you can have some panels landscape and some panels in portrait, it doesn't affect the strings, it doesn't affect the performance of the panels. So in certain circumstances, we'll mount the panels in a combination of both landscape and portrait as well. Yeah.
Okay, thank you. And just one last one. It's just an interesting enough one, I suppose, is on the factor of 0.8. So Stephen mentioned the factor of 0.8 used in the calculations, annual power generation. So just wondering, what's your own opinion, I suppose, on the 0.8 factor and where that can be improved, maybe?
I think it's pretty outdated to have the 0.8 factor built into it's. Like I said, we need to allow for the efficiency of the modules as well as the inverter, and a combination of what inverter and what module you use. At the moment, the formula is pretty generic. No matter you use an a panel from 3 years ago with much lower efficiency compared to a panel which has a 24% efficiency at the moment. So I think that formula definitely needs to be re-examined, and a better formula that takes as much input possible, that can differentiate between the different systems installed rather than just putting in the system size and putting in the predicted irradiance of that place. So yeah, I think it's outdated to still use the 0.8 factor into the formula.
Okay, thank you. I suppose maybe we better leave it at that, Stephen.
Yeah, I think so. Just to thank the guys again, and fair play for putting up with all the technical difficulties you had there and getting through it. So thank you very, very, very much for that. And and thanks everybody for bearing with us and sticking with us. And we'll be back, I guess, in the new year with another CPD, and obviously there'll be newsletters and stuff out there. So stay involved in that. So yeah, we leave it there. So thanks very much for everyone involved. Thanks John, thanks Barbara, of course, for organising everything, and of course Energywise. We'll talk to you soon.
Thank you.
Thank you.